Hello friends, welcome to my channel Technobuzz. In this video, I will show you how to import UNV file in OpenFoam 12 and the procedure to modify the files in OpenFoam folder structure. Before going into video, please do like, share and subscribe. Also click the bell icon to get notifications. So let's start. In this video, we will see how to import UNV file into OpenFoam. Based on convenience and other factors, geometry creation and mesh generation can be done using various CAD softwares like HyperMesh and others. OpenFoam offers provision to import various file formats. Today we will see how to import UNV file into OpenFoam. To demonstrate this, I have selected a simple lid-driven cavity as a demo case. I'll be using the Salome software to create the geometry and mesh. The details of the geometry are given here. I'll be creating two boundary groups, wall and source, and hexahedral elements will be created. Finally, the mesh will be exported to UNV format. In the simulation part, I will explain the procedure to read the UNV file in OpenFoam 12 and corresponding modifications to be done to the files in the folder structure of OpenFoam 12. And finally, the case will be launched and post-processing will be shown in ParaView. So let's start the video. First, we will create the geometry and generate the mesh in Salome and export the mesh data to UNV format. Open Salome and set it in geometry mode. Click create box and enter the dimensions in X, Y and Z directions. Okay, so this is the geometry. Then let us create the groups. Right click and select create group. Click this face option, then set the group name as wall. Now here we select the sides and bottom. So select this side, add, then select the other side and click add, then select the bottom and click add. So these three faces are selected and we define them as wall. Okay, now the next step, let us create a new group called front back wall. So here we select the front face, click add, then select the back side, this face, and click add. So now we have created front and back faces and click apply. Then create a new group source and select the top face and click add. Now let us create an edge group. For that purpose, just click this edge option and write edge, and here you select this edge and click add. So apply and close. So we have created the wall group, front and back face wall group and source. Along with these three face groups, we have created one edge group. So now let us switch to the mesh mode. Now here click box and then click the create mesh option. Here the geometry is box, mesh type is hexahedral. Then see that the create all groups in geometry. This option is on. Then click 1D, select wire discretization in algorithm, and in hypothesis select number of segments and set 30. Click OK. Then in 2D mode select the quadrangle mapping, and in 3D just select extrusion, then apply and close. Now click mesh 1, right click it and select compute. Now here we can see 27,000 volumes. Click close. Now if we want to reduce the mesh size in Z direction, we can do that this way. Click create submesh, and here for geometry select edge. Now in the 1D mode for algorithm select wire discretization and hypothesis as number of segments. Now here modify the segments to 20. Click OK. Nothing else is to be done, just apply and close. Now once again go to mesh and click compute. Here we can see 18,300 volumes. Now, so this is the final mesh which we have with face groups wall, front and back wall, and source. So these three face groups are selected as wall. So front and back wall, here we can see these two, and then source is at the top. Now click mesh and then export this mesh to UNV format. Save. So now we have created the mesh, exported it to UNV format. Now let us load this in OpenFoam and check. Now first create the user working directory cavity. Okay. Now let us copy the cavity case files from the tutorials. Now let us copy these three folders and paste in our working directory. Now let us copy the UNV file and paste in the working directory. Okay, now let us open the terminal. Set the path to the working directory. Now here are the files. Now let us import the UNV file. The command is ideas UNV to foam gap the UNV file name. Click enter. Okay, so here we see there is some error. Now this is due to when we have created the geometry, we have created an edge group like this. So this is the problem. So we need to delete this part. So we have to delete the data from this line up to here. No need to delete -1. Okay, close this file. Now let us try once again. Fine, now it is done well. So here we can see three groups. So let us explore further. Now first open the polymesh folder, which is saved in constant folder, and open the file boundary. Here we can see all the three groups which we have created: wall, front, back wall, and source. So these are the three face groups which we have created. So for wall, replace this patch with wall. For this group, replace the patch with empty. And for source again, replace it as wall. Fine. So this file is modified. Nothing else is to be changed here. Come back. Now here we see there are number of files in 0 folder. We want to run the case in laminar mode. So let us delete the files corresponding to turbulence. So these are the 5 files which we can delete. Okay, now open U. Here we can see 3 groups. Replace this moving wall with source. And this fixed walls, replace this fixed walls with wall. And replace this with front, back wall. Fine, let us copy this. Nothing else is to be changed. The velocity is in U direction. This file is fine. Now go to file P. Here to replace moving wall with source. Replace this fixed walls with wall. And replace this with, nothing else is to be changed here. Fine. So both the files are updated in 0 folder. Now come back and move to constant. Now open momentum transport. As we want to run the case in laminar mode, delete this block and replace RAS with laminar. So this makes the case laminar. Open physical properties and see, no need to change anything here. Close. So everything is done in constant folder. Now we'll go to system. Here we have to open control dict and modify the operating parameters. So the application is foam run incompressible fluid. So this is fine. So let us modify the end time to 100 and delta t to 0.001. Now the write interval, let us change it to 1000. So this means for every 1 second a result will be saved. No need to change anything here. Just close this. No need to change anything now. Now before launching the case, let us open the mesh in ParaView and check. For that purpose, type parafoam. So apply. So this is the mesh which is created. Okay, we can change the color and set the mode to surface with edges. So this is the mesh. If we want to check the coordinates, what we can do is, if you want to check the coordinates, you can click this field and click OK. Now you can check the coordinates of every point on the mesh. Okay. Further, it may be noted that if there is any problem in copy pasting the names of the boundary groups in the UNV files of 0 folder, then this paraview will crash. So then we have to check the mistakes and rectify them. Now in this current case, as the paraview has loaded the file, so there is no mistake. So now we can launch the case. Now let us close the paraview. Okay. Now let us launch the case. Form run and press enter. Now the case has started. Once the simulations are completed, we will carry on with post processing in paraview. The case has completed 100 seconds. Now let us open OpenFoam for post processing the results. So this is the geometry, and let us create a section mid Z and click apply. Select view in this panel and check the result at 100. So this is the contour plot of velocity. We can change the contour colors here. Okay. So this is the contour of velocity magnitude. Similarly, we can plot streamlines. I will create the animations of velocity contour streamlines. The animations of contour and streamlines are shown here. So I hope the procedure to load UNV file is clear. Should you have any queries, don't hesitate to leave a comment. In next video, I will present some function objects in OpenFoam 12 related to post-processing. Thank you for watching. Please do like, share and subscribe.